Alright, thank you, Marie Chris, for the nice talk. Uh, in our event announcement, I posted that I will talk about Mastodon, but I received two volunteer lightning talks that I just cannot release because they're much, much better than my talk about Mastodon. So I will yield the talk to them. I will just make an announcement. So for those curious about Mastodon, it's an open source software. It's like Twitter, and it's built on Rails. So it's like run your own Twitter on Rails. Run your own community. I have set up a server, and I plan to share it with the community, but not today. I will share my learnings in setting it up and running the server in subsequent meetups. So for tonight, I will yield the talk to Mikong, who will talk about another popular R-rank language, which is Rust.
Good evening, everyone. So I'm here to talk about Ruby FFI with Rust. Oops. So if you're not familiar with FFI, I'll explain it a bit later. So brief page about me. So I'm a software engineer. I previously worked for Engineered for 5 years. And I'm about to join Great Gecko, and I like contributing to open source projects, Ruby and Rust. So this is the basic outline of my talk. So very briefly, I'll define what FFI is, and most of the meat of my talk will be talking about Rust, since a lot of people are probably not familiar with it here. And then finally, I'll talk about the steps on how to do Ruby FFI. So FFI. FFI is foreign function interface. So a foreign function interface is a means for a programming language to interface with libraries written in other programming languages. So Ruby FFI is not like specific to applying it with Rust. Obviously, maybe you've heard of it before, where if you're running a Ruby or Rails application and you need to maybe speed up part of your code, or maybe there's a Python library that's not available in Ruby, you can do Ruby FFI to communicate with the library or your own custom function in that other programming language. So, but why Rust? So these three items are highlighted in the Rust official website. So performance, reliability, and productivity. I want to focus on performance and productivity for this talk, because actually in the site, in discussing reliability, it mostly discusses about the language features, Rust type system, the ownership model in Rust, which is a bit difficult to talk in a limited time. So we'll just talk about performance and productivity. So from the Rust website, Rust is blazingly fast and memory efficient with no runtime or garbage collector. It can power performance-critical services, run on embedded devices, and easily integrate with other languages. So this is actually an old performance comparison, and I'm not gonna get into the context of, because there's a context on when this comparison was made. The important part here is to have an idea of the level of performance that we're talking about. So this is Hello World HTTP server for different languages, Rust, Java. There's two for Golang, and then Node.js. And basically, yeah, for Rust, there's like 2 million requests per second. It can handle 2 million requests per second. Obviously, there are flaws with doing benchmarks like this, but you get the idea. And actually, if you notice, Node.js is very low there. I think a lot of Ruby developers, myself included, actually, when we implement, for example, a Rails app and we want part of the service to be very fast, one of our go-to languages is actually Node.js, because Node.js is very fast. But compared to Rust, it's actually the difference is very stark. So I got this image from Twitter. So they ported their Node.js API to Rust, and yeah, you can't read the numbers there, but basically the CPU dropped from 100% to around 15% once they moved to Rust, and the memory was halved. Actually, with later Rust optimizations, if you follow the thread, they halved the memory again. Um, so anyway, this part is actually not surprising and obvious. People immediately say, obviously it's faster because it's a compiled language like C or C++. So Rust is well known for performance and security. So we can move on to um, productivity. So Rust is actually the most loved language in the Stack Overflow developer survey for 4 years in a row. So from 2016 to 2019. Most loved, the way Stack Overflow calculates that, it's actually based on like the number of users, the ratio of the number of users to how many of those users want or love Rust. So it's not the most popular as I mark there. It's just the ratio of the users and how much they love the language. So and I think it's a big part of why people love Rust is because of the productivity and when they use the language they feel productive and they enjoy using it. And I put documentation here first because it's difficult to overstate how good the Rust official docs is. Not just the content but the usability. And this is apparent for me. I tried learning a few programming languages this year, and it's really the difference is really big. Like even compared to the Ruby official docs, I like Rust's official doc better. And I think some people joke in the Rust community that Rust is a difficult language to learn, so they have to make the documentation at least good. Otherwise, no one would want to use it. Yeah, and then there's also the official website actually has the book called The Rust Programming Language, or just the Rust book. And as I said, it's not an easy language to learn, but this book makes it seem like it's easy. So it's a testament of how much work the authors put into it, making it very easy to jump into. And then there's Cargo. Cargo is the package manager and great host for Rust. So it's like bundler in Ruby. In fact, Carl Lurch and Yehuda Katz, two of the creators of Bundler, were asked to join the Cargo team because they were also Rust developers, and they helped build Cargo. So if you use Bundler, it becomes it seems familiar to you. And as Rubyers, we sometimes take Bundler for granted, but for people getting into Rust from other programming language, they really see that Cargo is awesome, just like Bundler is awesome. And then there's the compiler. So as Rubyists, compilation is an extra step. So we're not used to having a compile step. But the great thing is that Rust's compiler has friendly error messages. If you encounter errors, it's very the error messages are well written, and it actually highlights which part of the code has the problem, and sometimes links you to the documentation that you need to read. So it again, this is probably because Rust is a bit difficult to learn at the beginning, so they want to make it as easy as possible to transition to learning it. And this is also the reason why Rust is secure, because the compiler does a lot of checks and makes sure that you're not violating or causing any memory access that's insecure or things like that. So it prevents you from making those mistakes. So people say that Rust is as powerful as C++, but feels like a high-level language. So it's powerful because it has the level of control of actually doing memory allocation yourself if you want to. So just like C++, Rust is a systems programming language because of its low-level programming features, and yet its syntax is nice and feels high level. So I obviously won't have enough time to show you a lot of the syntax of Rust, but I have an example here. So this is iterating a hash map in Rust. So you require the library, initialize it, and then there's a couple of insert there to insert key value, a couple of key values, and then the last for loop is basically to print all the keys and values from the scores hash map. So it almost, at least to me, it almost looks like Ruby. But you know, if we say that Rust is high performance, secure, very friendly documentation and all that, so what's the catch? So just as the compiler is very helpful, it's still an extra step, right? So since it needs to perform a lot of checks that it doesn't do at runtime, compilation can also be slow. And for beginners learning Rust, since Rust has a steep learning curve, when you try to understand the language, and if you're not yet familiar with those features, it can sometimes feel like you're fighting with the compiler. So I think probably most people who got into Rust has definitely cursed at the compiler at some point. But it's a good thing as well, because there's a reason why the compiler throws those errors. It's to help guide us to do the right thing. And well, it's a good thing that the docs are also well written and the messages are well written. So at least that can help. But I get a lot of questions from Rails developers or other developers when is it a good time to use Rust? So technically Rust is a general purpose programming language, so you can use it for anything that you want. But these are usually the applications that you can find people using it in. So when they say that they're using Rust, so there's like command line interface tools, network services, and so on. But I guess a more interesting question is for Ruby developers, for Ruby web developers. So when do we use it? So still, I would say if you need to build a command line interface tool, it's a good thing. When you compile Rust, you can compile Rust relatively easier to run on different platforms. And then if you have maybe a part of your system, network service that you want to be really fast, because Rust is very fast, obviously that's a very good use case for Rust. So maybe not a full web application, so it's not a good replacement for Rails, for example. But if it's a service API, Rust is good. And then I wrote here server agents. So if you have, there's some third-party services that like tracks or monitors or logs, our server logs or our server performance, for example, and you need to install an agent that will run on the server. Since Rust has very low CPU usage and very low memory usage, it's the ideal language for that kind of application. So Skylight, it's a New Relic like competitor. They use Rust for to write the agent and also log DNA. So some logging services use Rust. And then obviously background jobs is one of those things that we want to speed up. So you can also use Rust for that. And finally, if you can focus on just small parts of your application that's very slow that you want to speed up. So that's why we're talking about FFI. So Ruby FFI, the third part of the talk. So Ruby FFI requirements are these three things: C compiler, live FFI library, and the FFI gem. So for the C compiler, it's basically just Xcode on Mac and GCC or CLang everywhere else. And for live FFI, you can use brew install live FFI for if you're on Mac. And on other platforms, So in the official Live FFI GitHub page, they have instructions on how to build Live FFI from source. But if you don't want to install it from source, obviously you can check your platform's package installer. If you're an Arch, there's a package that you can install with Pacman or apt with Ubuntu. So there are also easier ways to install Live FFI. And then for FFI gem, just gem install FFI. And for the Rust library that we're going to interface with, I'm going to skip the part where I show how to build the Rust library and the steps to make the library accessible from other programming languages. I'll just show you the Rust function that we're going to call. So this is a very simple example. So here's a Rust function named add. Since Rust is a strong statically typed programming language, we have to specify the data type. So here, the function accepts two unsigned 32-bit integers, A and B, and it returns the same type, 32-bit unsigned, and the body is basically just A plus B. So this is just like Ruby, where the last value evaluated is returned unless you put a semicolon. So that's another similarity with Ruby. And we make a couple of adjustments here to make it interface. So the no mangle, that's an annotation there. It prevents the compiler from changing the name of the add functions, so that when you look for a function named add from Ruby, it will match, because otherwise the compiler might change it to something else. And then pub is just a keyword to make it public and callable outside the library. And then extern is another keyword to make the function, make this a function interface that other programming languages can call. So everything else is the same from the previous slide. So this is it, how to use FFI in Ruby. So you require FFI, and then you extend the FFI library, and then the next line there. So when I tried doing this myself, I named the Rust library live Ruby FFI, and then when I compiled it, the location of that compiled library is in target debug, and then so that's just the path of where the compiled library is. And then there's the part here that's for so basically, depending on the operating system where you're compiling, the dynamic library will have a different file extension. So that's the purpose of this last part. I'm actually going to show you what's in live suffix in the next slide. But the last part is basically how to attach the function to the main module. So that's just add the name of the function, and then the next parameter is the arguments of the add function. So these are the data types on the Ruby side. So a couple of ints, and then the return type is int. So here's live suffix. So yeah, it's just a case statement for the OS. For Mac, the file extension is dy-live, and then for Linux, it's SO for shared object, DLL for Windows, and so on. So again, that's the way to add the add function, and that's how you call it. So at the bottom there, you can see sum equals, so main.add, the module.add 2 and 2. So that's actually calling the Rust function simply by having these. So obviously, in your real application, you're not gonna interface with an add, so it's gonna be a more complicated function that you need to speed up. But yeah, that's it. So I'm Mikong. This is the Rust unofficial mascot, Ferris. You can find me on Twitter and GitHub as Mikong. Thank you.